Cyber-physical system for intelligent husbandry farm using OpenHub compatible IoT actuators and sensors. The article presents a model of cyber-physical system designed to control a smart farm. An overview of modern software technologies used to control cyber-physical systems is presented. Communication technologies used in remote control systems and in particular web technologies for data transition are considered. Modern platforms and software frameworks for realization of web services and provision of functions for remote control and monitoring have been studied. Based on the conducted research, a specialized model of cyber-physical system has been developed and presented. Based on the presented model, experiments were performed with different temperature sensors and humidity sensors. Introduction. Today, researchers are working mainly to improve the genetic basis for high milk yield of cows without paying enough attention to the thermoregularity ability of modern breeds. Therefore, within a given species, there are differences between the breeds in the adaptation mechanisms, mainly to heat stress. The main problems in rearing dairy cows have been and remain unsatisfactory hygienic conditions and microclimate of the production environment, disturbances in technological processes, poor performance of construction activities, and others, which are the cause of high mortality in cows, gynecological hooves, and musculoskeletal problems in cows, most of which are caused by heat stress during the warmer months of the year. Requirements for the establishment of cyber-physical system for intelligent management of animal husbandry farms. The main requirement for any livestock building is that it must provide the necessary living environmental conditions according to the psychological needs of the animals houses in it by technological modeling of natural microclimatic factors and achieving the desired technogenic environment. According to some authors, roofs with an incline of less than 18 degrees can cause high temperatures in summer and condensation. All changes in the barn temperature humidity conditions that unbalance thermonatural zone for dairy cattle can cause temperature stress. To determine whether animals are reared under conditions of temperature stress, the temperature humidity index is used. Values above 75 are generally considered as stressful due to the physiological changes that occur in the animal's body. Productivity trends in dairy cattle farms are often dependent on environmental factors. In the first place, among these factors is the temperature, which is a prerequisite for the occurrence of heat stress in animals. The microclimate in the barn, with its particular peculiarities, negatively affects not only the health of cows feeding, but also their reproduction and comfort. Body temperature is a key indicator of health, on the basis of which various health problems can be identified, as well as ineffective adaptation of animals to their surrounding environment. Those conditions, in addition to temperature, can be affected by relative humidity and air currents on both hot and cold weather. Concept of cyber physical system for animal husbandry. The cyber physical system is a new generation digital system that consists of two main functional components. extended connectivity, which provides real time data collection from the physical world and feedback from cyberspace, intelligent data management, analytics, and computing capabilities that make up cyberspace. The proposed model of cyber-physical system is based on open hub technology. The end devices are connected via cable connections to the gateway using the Modbus protocol. Then, through the MQTT protocol, the received data is sent to a web server that has connection to the graphical interface and the cloud. On the way back, commands can be sent to the end device. The proposed CPS model consists of three main blocks: web graphical interface, cloud, and open hub. Research and selection of open hub compatible IoT actuators and sensors. Based on the study for the main parameters characterizing the microclimate in a livestock farm and animal welfare, it has been selected the following IoT actuators and sensor for measuring and control of humidity, temperature, ventilation, lighting, dust, carbon dioxide level, NH3, and other important parameters. The sensors are light intensity sensor, temperature and humidity analog RS 485 transmitter sensor for farm environmental illuminance sensor. High quality NH3 sensor module RS 485 Modbus RTU PM 2.5 and PM 10 sensor SO S800 infrared CO2 carbon dioxide sensor, wind direction sensor, and wind speed sensor, high precision laser dust sensor, and electric curtains roller blind shade tubular motor. Preliminary tests with different sensors measuring humidity and temperature. In this figure is presented the combined humidity graphics from the different humidity sensors. In the next figure is presented the combined temperature graphics from different temperature sensors. The results of the humidity sensors show that all sensors have similar sensitivity. We can see that each sensor recognizes changes in the humidity. Only calibration is needed to achieve accurate measurement from each sensor. Temperature results show similar dependencies. Here is the same problem with the calibration. If we look for dependencies when comparing the two figures, we can see that a small increment of the temperature leads to reduction of the humidity. Similar dependencies will be included in the control system of the CPS, and that will provide intelligent and automatic functionalities. Conclusion: we can conclude that the monitoring of the factors forming the conditions under which the animals are kept is of special importance. Continuous visual observation and monitoring these parameters is very time consuming, takes a serious energy, human and financial resources, and these difficulties are a serious challenge. All this leads to necessity of automatization of this process. Proposed cyber physical system for intelligent husbandry farm is suitable open source solution for smart farming, giving maximum flexibility, user-friendly, cost-effective solution, which will lead to increasing of the efficiency of production. For future work, we plan to implement other components of the proposed system and to compare this system to similar cyber-physical systems. Our final goal is to design a cost-effective solution capable to provide all the necessary functions and tools for animal husbandry. Thank you for your attention.